My name is Arianna Bozzolo, and I'm the research director at the Rodale Institute California Organic Center. During this webinar, I will talk about several experiments we are carrying on here at the California Center. The specialty crop block grant project that I will talk about is titled Replacing Plastic Mulch with Cover Crops in Organic Vegetable Production Systems for Economic Benefits, Soil Health, and Environmental Stewardship. But I will also talk about other two experiments that we are carrying on here at the California location, where the main topic is soil health along with weed control. So I will first, in this presentation, I will first review different types of weed management. I will briefly talk about cover crops, of course, and termination and management. And I also have a few slides about intercropping and the advantage of this production system, ancient production system. But before to start, we have some housekeeping information. So I hope you can hear me. If I'm not audible, so if you cannot hear me, click on outside and on your screen and see if you can fix it. If you cannot fix it, you can call Maria Pop, our education director, at 610-683-1481. In our location today is windy. Hopefully we won't have any issue with the connection, but in case the connection drop, I hope I will realize that, and I have a second connection in case we need to. For question and answer, we'll need to wait the end of the presentation. You can use your question and answer button on your screen. Please don't send question in the chat function. If you do, I might see them later and answer. If you want to send specific question or get in contact with me, I will easily find my contacts information on the Rodale website. This presentation is recorded and it will be posted on our website in a week. And to better focus on the presentation, I will turn my camera off. And now we can get to it. All right, weed control. I don't think I need to have we don't need a definition of weeds. If in your life you grew even a potted plants, you probably had to deal with weeds. Weeds are plants that are growing where they are not supposed to or we don't want to. And they are totally fine plants. They are great. They're soil indicator. And they can even be healthy for us, like the stinging needle, the urtica. But they're still growing where we don't want them, and they can compete with our crops. So we need to control them somehow. We have two main types of weed control, that is the physical control and chemical. Physical control options include shading, hand weeding, rotations, and mulching. All of these systems are very labor intensive, but they have advantage of targeting the weed in questions. Shading seems to me is very interesting method. We have our field is surrounded by other small farmers. One of them is really into Korean farming, and he used this technique where he just tarp with a dark cover the rows that he wants to use later. And he says that about for the field stay clean for about 6 weeks. However, it takes time to get to that point. So as I said, is time consuming. Hand weeding is great, but it can be very expensive. We can go up to $200 per acre. But it's also considered like tilling. We kind of disturb the soil while we are pulling weeds, and not as deep as it's not a tilling like as a plowing, but still will disturb the topsoil. And then rotation and mulching. Mulching is great for perennials. To keep weeds under control with mulching, you need a lot of wood chips. It can work great in perennial systems, and you also are increasing the soil organic matter. For the chemical control, there are often several herbicides available to control a particular weeds. Always read and follow the label instruction regarding safety and dosage rate. So everything you need to know about the herbicides are on the label. And the herbicide label is a legal document, so is the law. It provides important information about the herbicides, how to use it, and the precaution needed to avoid off-target movement to protect environmental quality. Of course, never spray with the wind. That I don't know if it's on the label, but when the wind is more than 10 miles per hour, I would avoid any type of course, spraying herbicides, but spray anything. And also, I wouldn't work the soil because of the risk of soil erosion. So a herbicide label answer what, where, and when, and how. Question about product. Herbicides are classified in different ways. One of them is how they are used. In this little table, we have this classification. The pre-plant herbicides are applied before planting the crop, typically several days, so we don't damage our cash crop. An example is the glyphosate. Pre-emergent herbicides are applied before weed seedlings. Example is simazine. Post-emergence are applied after the top seedlings have emerged, so when we have the little tiny weeds, like the 2,4-DB. And we can spray herbicides when the plants are already established. So the rooting system is enough developed to uptake the herbicides. Herbicides are also classified as to their selectivity, can be selective when is formulated to control a specific weeds of weeds category. A material that is toxic to some plant species, like the 2,4-D, and non-selective, very well known, is the paraquat and the glyphosate. Another classification is if the herbicide is per contact or translocated. I want to do a quick reminder that herbicides are very dangerous and they're lethal. There have been instances where people, for example, used unlabeled container to transfer herbicides from the main container to the tank. And there's people that by mistakes drank the herbicides like the paraquat, and these are lethal products. I highly suggest, if you use herbicides, to look into the APA.gov website, because there's very interesting information. And yes, we use these. We don't use herbicides on our food, but we use it on the soil. But sometimes we can find residues of these herbicides in our food. So I'm not a big fan of herbicides. So mulch is a way to keep weeds under control for the most part. Mulch is one of the practices that enters the classification of plasticulture. The term plasticulture refers to the practice of using plastic materials in agriculture applications. In these slides, we can see the different products that are used in agriculture, plastic-based, that include drip tapes, nursery trays, containers. There is a picture of Almeria in Height in Spain, where the soil is completely covered by high tunnels, very common here in California too, and the plastic mulch. Some of drip tapes can be recycled, but most of the plastic, it goes just to the landfill. So this is something that a picture that I commonly see in our farm. We are working in an organic farm, so I want to point out the difference between organic and regenerative organic. The use of plastic mulch is not regenerative organic. This plastic goes to the landfill. As I said, We are starting a collaboration here in California with a group nonprofit that is working on biodegradable plastic mulch. There's some like a prototype questions that needs to be answered is if this biodegradable plastic is really biodegradable or it just becomes in small pieces and we cannot see it. What happens to the soil and the microbial population when we use plastic, bioplastic? On the agronomic side, we wonder how long this plastic can last, because an issue that growers had in the use of bioplastic, it doesn't last long enough, especially on a crop like strawberries. And there's been done some study with the matter B, that is one of the bioplastic. There's some good results, but one of the issues that the growers found is that the machine that is used to lay down the plastic, it doesn't work very well with the bioplastic because it's too thin and it breaks while it is going, the plastic is laying down. So I think there is a potential, definitely a need of bioplastic because people really like it. We still need to figure out what happens to the soil. I'm not totally sold on that. I still like cover crop better. So about plasticulture. So the innovation was started as an agricultural benefit when it was first introduced in 1950s. Since its introduction, plastic mulch has become a standard practice used for many farmers for weed control, increase crop yield, and shorten time to harvest. Farmers in cooler regions use plastic to hasten work. For example, while in the US, southern US, farmers use plastic to cool the soil and plants. There are different colors. Has been estimated that US agriculture alone use about 1 billion pounds annually, and that includes, as we saw, mulch, greenhouse cover, wrap bales, tubing pipes. It also includes nursery containers, pesticide containers, silage bags, storage covers, and twine. Plastic mulch has been widely used to increase crop yield worldwide. The use of plastic mulch can increase crop yield on average by 25–40%. That is a lot. In the immediate season due to increase of soil temperature, it is about 8%, and moisture, 17%. The use of plastic mulch on cropland has increased dramatically in the recent decades, reaching over 1 megaton annually, and about 60–80% is used in China. In fact, Chinese researchers are looking into bioplastic. Most of the research are done in China. As a large portion of plastic mulch used are not recovered at the end of the crop season, plastic film residues has accumulated in croplands. A lot of this plastic cannot be recycled because it's not clean. The impact of plastic residues in cropland soil to soil health and crop production in the long run remain unclear, and plastic pollution in cropland threatens long-term food security. So when plastic moves through the food chain, the attached toxin can also move and accumulate, and we call this process bioaccumulation. Okay, how can we manage weeds without plastic? Crop rotation can be part of the solution. So when the variation in crop species and planting time is essential, as crop rotation creates changing environment and prevents weeds of certain species. Flaming can be used as a pre-emergence practice to control broadleaf weeds for emerging. Well, we use it here. This is an actual picture that we took in our field. I think it's a little bit dangerous because here it's really dry, but it can be can be fast and efficient. Just need to be very careful. And then organic herbicides, non-synthetic herbicides with no residual activity, such as acetic acid. Well, they work, but it's like they just burn the top part of the plants, and most of the time the plants grow back. So they are not really, not a big fan of the organic herbicides. Let's see if I can change slides. Okay, we can also use a cover crop for weed control, and they can also bring additional environmental benefits. Cover crop can increase soil organic matter and improve soil fertility by capturing excess nutrients after crop is harvested. They can also raise soil moisture holding capacity, prevent soil erosion, limit nutrient runoff, reduce compaction, and can also suppress some of pests. What to plant? It really is a very common question. Well, depends what are your major risks are, what you want to, what you are targeting. Here I put a very rough list. And for erosion, especially in perennial systems, for example, in slopes, I'm thinking about vineyards, we can use cereal like rye. For compaction, I put beets, nematodes, brassica, but there's also some interesting research about lychee tomatoes that seems working for some of the nematodes that affect the potatoes. I read for grapes is not, it didn't work very well, but I think there is potential. For in case of drought, I would suggest clover as an annual. Weed control veg, biodiversity buckwheat mix, and for soil health, I would use a mix. I'm a big fan of buckwheat, not really for weed control that we tried in these experiments that I will show you, but for increasing biodiversity, especially I'm thinking about vineyards. Has been demonstrated it doesn't reduce vigor, and so it doesn't have an impact on the plants, but it can be it can increase biodiversity and having all the advantages that cover crops can bring. Another thing that cover crops do is, along with other regenerative practices, is increase resilience in our systems, in our field. So it means that our field, our vineyards, or our system will be more resistant to extreme weather events. So resilience is the degree to which an ecosystem can resist or recover rapidly from environmental perturbation. So we want our system to recover as fast as possible after, for example, a flooding or extreme drought. Another very interesting area related to cover crops is the allelopathic effects that cover crops can have on germination of seeds or weed seeds. Allelopathy is a common biological phenomenon by which one organism produces biochemical that influence the growth, survival, development, and reproduction of other organisms. Allelopathic cover crops such as rye, sorghum, Sudan grass, mustard, oat can inhibit germination of weed seeds. And these biochemical are known as allelochemical. It have beneficial or detrimental effect on a target organism. Well, let's say the advent of modern herbicides actually permitted the no-till system to be developed and actually practiced on actually working farm. Well, data from the Agriculture Resource Management Survey on the production practices of corn, cotton, soybean, and wheat show that roughly half, like 51%, use either or no-till or strip-till, at least of the farm, at least once in the past 4 years. So the no-till system is becoming more common. And just to reminder, the negative impact of tilling include like tillage is fracture the soil or disrupt soil structure, accelerating runoff and soil erosion, and most important, disturbs the microbial community. Okay, how can we terminate a cover crop? Termination methods for cover crop can be chemical or mechanical. or the combination of the two. Chemical termination of cover crop with a non-selective herbicide is common because it can be applied at any time, any growth stage. Most spray equipment coverage, it's easy because it covers a large number of acres in a short period of time, and that it's really useful when you have a window of seeding and or doing your things, your practices in the field. High residue cover crop may lodge in many directions after chemical termination, and this can negatively affect subsequent tillage or planter operation. I never use herbicides in an open field, but I did use them in a vineyard. Usually in conventional farming, we spray pre-emergence or post-emergence, but sometimes you miss the window and you end up with weeds under the row. So when we spray weeds that are already developed, they will die, but will still stand. They're not laying down like they're, I don't know, frosted. And can be a challenge for seeding, even for corn, if you have a standing straw, basically. So either with or without herbicides, we can use we can use to flat the residues. Mechanical roller crimpers lay residue uniformly on the soil surface, parallel to the direction of planting, and the residue form a dense mat that help in early season weed control. Field operations are typically easier when residues are laid flat, parallel to the direction of planting. Standing cover crops that have been sprayed are more susceptible to wrap around the shanks or the disc and kind of slow down the field operations. Roller crimpers in general consist in a round drum with blades, blunt blades, not sharp, mounted across the face of the drum. The traditional style is consists in evenly spaced blades, but the spiral has become more common because it produces, they say, less vibration. Several types of roller crimpers has been developed, and many growers have modified existing design to fit their situations. We have one at the farm that we want to try. It's not a real roller crimper, but we want to try to see if it works. So roller crimper can be front mounted or rear mounted on tractors. Front mounted roller crimper enable another implement such as the planter or the sprayer to be mounted behind the tractor, and that saves money a trip across the field, so money consequently. The roller crimper terminate the cover crop, bending the stems, and it causes to desiccate, to dry. But the timing of the roller crimper operation is critical, especially if we rely only on the roller crimper without herbicides or other chemicals. So delay using the roller crimper until the crop is flowering or later may or may not be successful. So here we have in the picture the traditional called Brazilian type roller crimper that consists in a steel drum with attached crimping bars. That's not very widely adopted in US because of, as I said, the vibration of the crimpers. New types of roller crimpers being developed that generate less vibration, like the right one, the spiral one. But sometimes the spiral one with this design, it does not generate enough force to kill the plants. So with this design, it's suggested to use the herbicide as well. Blunt blades are preferable to sharp blades because they crimp other than cut. When we cut or chop, the biomass is separated in two parts. So the loose part can become oriented wherever the direction of the wind is, and it can cause trouble with the equipment. It can also fly away if it's really windy, like today, and so your mulch will be gone. If the material is crimp, then it tends to lay flat in the direction of the rolling, which reduce the tendency of the plant to wrap around the planter. Okay, I'll do a little bit faster. This is our roller crimper. This is the Rodale designed, and so the specific characteristic is that the chevron design, with that design, will be able to crimp in multiple spots, in general 5 or 7 part, our cover crop, to have a better termination without the use of herbicides. I think it's also important to remember that these drums can be filled, actually has to be filled with the water, and that will help the efficiency of the termination. I will skip one because we are getting short with the time. About intercropping, another way to use cover crop is intercropping. Intercropping is basically the cultivation of 2 or more crops simultaneously in the same field. The advantages are improving efficiency of resources utilization, and that has been demonstrated all over the world. It's a very ancient technique. Basically, you can produce more food in less land, but sometimes it's hard to mechanize this system. Intercropping is widely used as an important means to provide food security, diversity of cropping system, and this is important, especially when you cannot rotate your crops. So you can grow 2 crops at the same time. It's kind of a rotation. It promotes sustainable agricultural development and efficiently utilize limited labor on smallholder farms, especially in small farms. It's really efficient. Can increase the utilization of our resources like light, heat, water, and fertilizer to effectively improve primary production per land of land per unit area, thereby making a significant contribution to global food security and increasing water production efficiency and economic benefits for farmers. Here I put these slides where we can see different research experiment about intercropping and the water use efficiency of growing 2 or more crops at the same time. We can see there's been the research has been done in several countries: China, India, Brazil, USA, Egypt, Nigeria, South Africa, Austria, Canada, Iran, Kenya, and Argentina, with different type of consociation or intercropping. I think Europe, and especially France, from my knowledge, was a leader in the 1500s of what they call French intensive farming or gardening, and it was basically intercropping in urban horticulture. The water consumption of intercropping during the entire growth period is greater than of monoculture. So most of the time, 2 crops will use more, 2 solo crops use more water than crops that is being grown together. For example, corn and peas, when they are grown in strip intercropping with the model 4-4, with 4 rows of corn and 4 rows of pea, we had a reduction. Has been demonstrated that there's been a reduction of 10-13% of the water consumption compared to the soil cropping systems. We didn't have the same results when we grew corn and pea in a different model, like 2-4, with 2 rows of corn and 4 rows of peas. In this case, the water consumption actually increased, and they also found that water consumption is not affected by nitrogen fertilizer, and it is greater than the salt pea, but do not differ with that of soil corn. Another example of intercropping is corn and wheat. They found that when we limited, there is a limited water supply at brooding stage for the wheat. It has been shown that practice save 15% of irrigation water and reduce water consumption that goes from 4 to 8% without reducing crop production. Reduction of water consumption by intercropping is based on reasonable crop collocation and appropriate irrigation fertilization, as we saw for model. Water consumption can be also reduced by optimizing tillage practice and mulching methods, reducing tillage with straw in wheat corn intercropping has been shown to reduce water consumption. So these findings show that water consumption can be reduced with intercropping compared to a monoculture. Also, soil evaporation in relation to intercropping. So the evaporation is the movement of water directly to the air from sources such as soil. Previous studies have shown that soil evaporation during the growth period of intercropping was greater of the soil cropping in different type of consociation. That indicated intercropping has a significant advantage over soil cropping, improving water availability. Over the years, research has revealed strategies to reduce ineffective field water consumption, such as soil evaporation, through optimization of irrigation level, fertilization system, mulching methods, and tillage practices. Now we are going a little short on time, so I want to actually go to our session about our site, the California site. So in this, the California Organic Center is one of the regional centers that the Rodale Institute established in the past few years. Very quickly, we are located in Ventura County, where and here you can see how the main crops are distributed in the county. In green, you can see the avocado and lemon in yellow, so perennials, and then on the we have row crops in blue. And this is the Oxnard plant. Is one of the most fertile soil in the whole United States. These are the top 10 crop of the county on a money value. So we have strawberries first leader always, and then lemon, nursery stocks, avocados, raspberries, celery, tomatoes, peppers, blueberry, and cabbages. The first 5 or 6, they'll never change. They're always the same. Here we have a big corporate agriculture corporate that lead the industry, and lead the industry for strawberries, but also like raspberry and blueberries. So this the Ventura County is the 11th county more productive in the United States. We have about 2,000 farms. These are the 5-year comparison of Ventura County crop grouping values. We can see how in the past few years the crops changed, the field crops especially. 2019, Ventura County was a huge, there was a boom of the CBD hemp growing. So in 2019, 2020, we had we have about 3,000 acres, but then the market was flooded and the numbers went kind of back how they were before the hemp boom. Regarding organic land in this area, we can see how the acres changed from 2020 to 2021. This is the most recent data I could get from the Commissioner office. And it's we can see how the total of acres and value is increasing in the county. So the Rodale Institute California is, as I said, one of the regional centers that Rodale established. We have the same mission and vision that our main ship has in Pennsylvania, but the big difference is that we are in a different location. We are in a different environment. So we are in the coastal climate on the yellow area here. What we're trying to do here is to develop system, the regenerative and organic system that maybe Pennsylvania already has nailed down with the roller crimper and cover crop, but we are working on row crops, in this case strawberries and artichokes. Is the first experiment, but we want to work the system for several for general vegetable production. I think the most important thing is that we want to look into is to find the right combination of the cover crop and the specialty crop that we can grow with that specific cover crop system. So one of the first things that I noticed when I got to US, to California, is the plastic mulch that is used to grow strawberries in this area. And this on the top left is kind of a dramatized picture because it's black and white, but it really the landscape that Ventura County has, and I think is not pretty. It is not sustainable. So we wrote this grant for the specialty block crop grant that we were awarded. We started last summer, late summer. And in the experiment, we want to evaluate the effectiveness of using living mulch, so intercropping and cover crops, coupled with no-till for weed control in artichokes and strawberry production compared to the standard plastic mulch. But we could compare with bare soil too. Some of the most common specialty crop are grown on plastic, but some of them are just grown on bare soil. And again, for organic production, bare soil is obtained with hand weeding most of the time. I included this picture because we see the plastic mulch as a silver bullet, but it is not. It definitely helps in many ways, heal and keep moisture, but it still needs to be weeded. If you notice on the right part of this picture, you'll see the strawberries that's being weeded. On the left part were not weeded. They're all grown the same way on the plastic. I would just want to point out that the plastic doesn't keep all the weeds down. They still need to be weeded by hand on the bed and in the furrow as well. With the furrow, you can use the tractor, but on the bed needs to be done by hand. So plastic helps, but it's not the total solution. For the artichokes experiment, here we have the design, and we have a randomized complete block design with 4 replicas. We transplanted the artichokes in October, and in December we did the last of the treatment. So going through, we have the plastic mulch that is our control. We had a buckwheat and pea mix cover crop, crimson clover as a living mulch, white clover as a living mulch, and curapia as a living mulch that was transplanted in December. Curapia is a ground cover that is used more like a turf, and I thought that with artichoke works well. Now we transplanted in December, but we had some really heavy rain in spring. It will come back. It will grow. It's still there. This is the strawberry part of the experiment. So this grant is divided in 2. very similar to the artichokes. We actually started before the strawberry, before the artichokes. And in this case, I have the control as the plastic mulch as a control, buckwheat and pea mix as we saw for the artichokes. Here, however, I have two sorghum Sudan grass in 2 rates and white clover intercropped. We are collecting data on soil routine and soil health. We are taking samples for cover crops, biomass. We did it before and after transplants of both artichokes and strawberries. We didn't start yet for the cash crop yield and yield components. We will start in March with the picking strawberries and hopefully artichokes too. We have soil moisture sensors placed in the field. We had some little issue with the last rain because half of them were damaged by lightning, so we'll need to do our measurements by hand, but we are still taking the measurements. And we also will have a budget analysis at the end of the experiment to see what's the economical aspect of these different systems. Here is I want to show you some of the moments when we did implement it. In this picture we have the strawberries. We use the steel pipes to pre-irrigate. They're very not efficient and very heavy to move. Then we cut the beds with these implements. However, every time we cut beds of 60-inch, these are 60-inch beds, we need to shovel to close the bed. So there is a lot of hand work. With this piece of equipment, we roll the plastic on the control and the drip irrigation, and then we seeded the cover crops by hand. I know it's not ideal for grower equipment to do it with a tractor. So we use here we have the picture of the buckwheat and sorghum when they were at germinations, and we also used this fabric that is for cold and insects to facilitate germination. It really helps. This is how it looked after a couple of weeks. We took the fabric out, and here you can see the actual randomized box with the for it, because these are some pictures of the roller crimper when we crimp the sorghum at the dot stage. So the first 2 pictures are of the sorghum, and the 3rd picture is actually buckwheat. You can see the buckwheat, it doesn't really cover much. And we can see also some of the peas mixed here with the sorghum. Well, the roller crimper, this model is for raised beds. It did work partially for a little bit. I think it would be better to crimp it multiple times. We didn't put water in the drum, and that might affect the efficiency of the roller crimper. However, the sorghum is not the best cover crop that need for in association with the roller crimper. Here we'll go through really quick to some of the results. We had definitely a better germination of the sorghum and better coverage for the sorghum. One thing that it seems a little odd is that we have a higher biomass on the lower the sorghum one have very thick stems. So I think what gave it the higher total ton per acre biomass. So it was thick. The stems were thicker. Here, regarding the type of weeds that with this system could be managed, the buckwheat, as you can see, didn't give me much of the of weed control. Sorghum works great for both grass and broadleaves. The problem is that it doesn't die, it keeps coming back. But as a weed control, is great. So what we learned so far, that definitely we need a special equipment, especially when we work on raised beds. The fabric, insect fabric protection, fabric improved germination. Buckwheat is a great cover crop, and it will flower in 50 days. We had some issue watering the cover crop that is not ideal, especially in a period of drought. And when we did, we had some issue with the chlorine, so no direct water on sorghum. We had some challenging with irrigation system, because usually strawberries are not grown on cover crops. So when we use the drip irrigation that is normally used for strawberries, I don't have a good germination on the whole beds for the cover crop. Crimp with the wind, especially when it's so windy, we have 30 miles per hour. If you crimp against the wind will help the cover crop to come back. And definitely we are happy with how the sorghum provide the coverage and biomass for weed control. We have other 2 experiments ongoing that I will really mention really quick. This is the Healthy Soil Program. In this case, we are actually we started working in the soil yesterday. In this case, we'll try oat and veg, oat and pea mix, teal, no teal, and bare soil with pumpkins and cabbages. So this will start now. We'll see the cover crop as soon as possible. Then we'll crimp it and we'll transplant or seed the pumpkins so we should have pumpkins for Halloween. This is how the randomized block set up for the Healthy Soil Program. Then a second specialty crop experiment has been established last week. In this case, we'll try the system with the rye and pea on zucchini, pepper, and eggplants. And this was my last official slide. Here I have some pictures of when we started the specialty crop experiment. And I'll go very quickly on a Q&A. Traditionally, hill farmers were used regenerative agriculture, and plant biomass were used as mulch and adding fertility, but now plastic mulch has been used as an innovation, and now farmers are confused what to do. Well, hill farm is, I think, cover crop can actually work better than plastic mulch for erosion, especially when you are working on slopes. Can you elaborate in detail some of the negative effect on plastic mulch on soil health? Honestly, I cannot yet. I will see from the experiment we are running what is going on under the plastic, so I can compare the community from where it can, when I get the samples from the cover crop and where I have the plastic, so I can actually see the difference. It's I mean, when you move the plastic, you can see it's very salt is accumulated. I expect that I have less microbial community. I don't know how long this effect will last for the soil. What is the fabric covering you show made of? It is plastic free or toxic chemical? It's used for organic. Honestly, I didn't think about it. since we are not, it is very temporary. We seed it, we put the fabric on, and then after a couple of weeks we take it out. I bought it at Johnny Seed's website, so I think we can check it and see what is made of. What happened with strawberries and artichokes yield and results? I don't have them yet. We are working on the soil moisture data, but we didn't start harvesting yet. So we'll have some more numbers. Hopefully in next month, we'll start with picking the strawberries. Which weeds compete with crops? Well, all of them. I would say it depends from the crops. For example, with the artichokes, that are very, they establish very quickly. They do not have very many issues with weeds, but other crops can be more sensitive, like the strawberries. When can I find information on when is the right time to kill the cover crops? Definitely on a Rodale website, you'll find information on that. You can also reach out so we can see which cover crop you're talking about. Most of them at flowering or at dot stage. But yeah, it really depends which cover crop. Well, I guess I did go over my time. I really thank you, everyone, for the patience, and sorry for the connection. And I hope you learned something new today. Thank you.